All right, guys, so now that we know how to complete the square, let's start using that skill to now solve polynomial or quadratic equations that we were previously unable to solve. So let's take a look at our first example. Always our first go-to strategy for solving a polynomial equation is, can we factor it? And you know what? I just don't think that this polynomial factors, at least not using the skills that we have. So we need to come up with a different strategy. Would it be possible to just isolate x squared on one side of the equation and just a number on the other? No, that's not going to work either. So our first two of the strategies we talked about earlier aren't going to cut it. We're going to have to solve this using a third strategy. We're going to have to solve this using completing the square. So here's the first thing I always like to do when I know I'm going to solve an equation by completing the square. Usually with polynomial equations, you get a 0 on one side. Not so once we realize we're not going to be able to factor. I'm going to go ahead and just add 6 to both sides of this equation. I kind of want to get rid of that constant term, if you will. So x squared minus 4x, I'm going to leave a space, equals 6. Okay, here's the deal. Now we need to add that number. And of course, what we do to one side of an equation, we got to do to the other to keep it balanced. We need to add a number here to transform this into a perfect square. I hope you know what that number is. That number is going to be 4, right? We take half of the linear coefficient, so half of negative 4 is negative 2, and negative 2 quantity squared happens to be 4. So we're going to add 4. Of course, what we do to one side of the equation, we must do to the other. So the left side of the equation, I hope you now believe, is going to be, we can rewrite that as the quantity of x minus 2 squared equals, 10. And remember, this was the third strategy that we talked about earlier for a way to solve a quadratic equation. Isolate x plus some number or minus some number squared equals some constant, in this case 10. And remember, if you tell me that something squared is equal to 10, well then I think that something could be the positive square root of 10, or that something could be the negative square root of 10. Well, all right, what is that something in this case? X minus 2 could equal the square root of 10, or x minus 2 could equal the negative square root of 10. From here, it's just a matter of adding 2 to both sides of each of these equations. And we find our two solutions to this quadratic, namely, x equals 2 plus the square root of 10, amazing, or x equals 2 minus the square root of 10. Some people like to write this as x equals 2 plus or minus the square root of 10. I'd be okay with that. I prefer these two. I just think it's a little more clear. And so we just solved our first equation using completing the square, right? We couldn't solve this earlier using factoring. We had to turn to something different, and this is why completing the square can be so helpful. One kind of note is, you see how our solutions in this case involve irrational numbers, in this case the square root of 10? That's why we couldn't factor really earlier using the skills we had. The skills we had earlier tend to extend only to when we have nice rational solutions. Okay, let's do another one. Here we go. All right, so in this case, we have something in a different form. Let's go ahead and let's check and see if this can factor. I think it's always a good idea to check and see if it factors. I'm going to subtract 9 from both sides, right? When we're trying to factor, it's all about getting one side of this equation to equal 0. All right, question, does this factor? No, it doesn't factor. Okay, we're going to have to go ahead and use completing the square in this case. All right, so the first thing I like to do is let's get rid of that constant term, just so we have a nice clean slate to work with. I know we're going to be adding something, I don't know what yet. The right-hand side, we have 5, and of course, if we add something to one side of the equation, we must add it to the other. Okay, what is this something that we're going to add? Do you know? I hope you know. That something is going to be 16 in this case, right? Half of the linear coefficient is 4. 4 squared is 16. What we do to one side, we must do to the other. I hope you know that we have now transformed the left-hand side of this equation into a perfect square trinomial. It is x plus 4, quantity squared. The right-hand side is 21. Boom! Let's take the square root of both sides of this equation, right? X plus 4, the thing being squared, well, x plus 4 could be the square root of 21, the positive square root of 21, or the negative square root of 21. Awesome, awesome, awesome. Subtracting 4 from both sides of our equation here, we find our first solution, x equals negative 4 plus the square root of 21. Amazing. And our second solution, after subtracting 4 from both sides, we find that x could equal negative 4 minus the square root of 21. Awesome, awesome, awesome. And I even invite you to go ahead and you can substitute these values back in to the original equation, and it would actually make it true. I mean, it'd be a lot tougher to multiply out, but it totally would make it true. And so I hope you're getting the sense of how to go about solving these polynomial equations by completing the square. I'm going to walk through these next two, but I urge you to maybe even pause the video and try them on your own first. Okay, so in this case, ooh, it looks like it might factor, doesn't factor. Womp womp. Okay, let's complete the square. I'm going to go ahead and subtract 7 from both sides, get rid of that constant term. X squared plus 6x, we know we're going to be completing the square, equals negative 7. What we do to one side of an equation, we do to the other. Half of positive 6 is 3. 3 squared is 9. I'm going to add 9 to both sides. The left-hand side is a perfect square trinomial. It is x plus 3 squared. The right-hand side, we get 2. If you tell me that something squared is equal to 2, that something better be equal to the positive square root of 2, or that something better be equal to the negative square root of 2. So we find that x plus 3 equals the square root of 2, or x plus 3 equals the negative square root of 2. Subtracting 3 from both sides of the equation, x equals negative 3 plus the square root of 2, or x equals negative 3 minus the square root of 2. Again, if you really want, you can say that x equals negative 3 plus or minus the square root of 2. Not as big a fan of that notation, but if it makes you happy, go for it. All right, last one I want to take a look at. Please try this one on your own as well. I hope you try them both on your own. This one's very interesting because actually, if you try to factor this one, it does factor. Check it out. We get x squared minus 8x minus 9 equals 0. This factors as x minus 9 times the quantity of x plus 1 equals 0. So x equals 9 or x equals negative 1. Amazing. But you know what? Just for fun, I want to show you that you can use completing the square in this example too. All right. So we already know what our solutions are going to be. They're going to be 9 and negative 1. Okay. So either way, if we're going to complete the square, I still want to get rid of our constant term. Let's get rid of that 4. So we've got x squared minus 8x plus some unknown, right? We're going to be completing that square. Maybe I'll zoom out a little bit. Equals, let's see, 9 plus some unknown when we complete the square. Okay, well, what is the number we're going to have to add here? Half of negative 8 is negative 4. Negative 4 quantity squared is 16. We're going to add 16. All right, the left-hand side of this equation is a perfect square. It is x minus 4 quantity squared. The right-hand side, 9 plus 16 is 25. Oh, ding, 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 ding. Note to self. When we take the square root of both sides, 25 is a perfect square. We're going to get some nice rational numbers, right? If you tell me that something squared equals 25, that something better be equal to positive 5, or that something better be equal to negative 5. Aha! We end up with x minus 4 equals 5, or x minus 4 equals negative 5. If I add 4 to both sides of the equation, our first solution that we end up with is x equals 9. Is that one of the ones we got before? Hot damn it is! All right. And if we add 4 to both sides of our other equation, we find our other solution, x equals negative 1. Hot damn, that was the other solution. So, hey, listen, solving by completing the square always works. Even if you could have factored in the first place, is it a lot more work? Yeah, it's a lot more work. So, I really only use completing the square if I have to. All right, I hope we're feeling good with this. I do have to say, things get a little trickier when the coefficient on our x squared, our quadratic term, is not 1. All of the squares that we've been completing, they have always had an x squared, just regular x squared, 1x squared. Now we're dealing with, in all three of these examples, I went with a 2x squared, but the strategy we're going to learn here applies when you have a 3x squared or a 7x squared or what have you. And completing the square, I don't even know how to do it unless I have just a regular 1x squared. So I kind of asked myself, well, what are we going to do in this case? Well, we have an equation, and what we can do is we can multiply both sides of the equation by the same number, or we can divide both sides of the equation by the same number. And you know what I'm going to do? If I have a 2x squared, and I want a 1x squared, I'm going to divide the left-hand side of the equation by 2. I'm going to divide the right-hand side of the equation by 2. One thing that's nice is that 0 divided by 2 is still just 0. So not a lot going to happen here. On the left-hand side, we're going to have a 1x squared. Hurrah, hurrah! We'll have a 2x minus 3 halves equals 0. And you know, now we're just going to go through the motions, just like we did before. Exactly the same strategy. It's nice because we have a nice even coefficient on our x term, which is pretty great. Well, maybe you know how to do it. Maybe you want to take it from here. Maybe you want to pause the video and try. But I'll walk you through it anyway. I'm going to add 3 halves to both sides of this equation. So we end up with x squared plus 2x. We know we're going to be completing a square. Equals 3 halves. And of course, what we do to one side of the equation, we must do to the other. Half of positive 2 is positive 1. Positive 1 squared is 1. We're going to be adding 1 to both sides of this equation. The left-hand side is a perfect square trinomial. That is x plus 1 quantity squared. The right-hand side, definitely best to write this as an improper fraction. Definitely not so great to write it as a mixed number. So I think this is going to be 5 halves. All right. Well, from there, we're ready to rock. Let's take the square root of both sides, or we can just go ahead and say, listen, x plus 1 could be one of two things. It could be the positive square root of 5 halves, or x plus 1 could be the negative square root of 5 halves. And from there, subtract 1 from both sides. X equals negative 1 plus the square root of 5 halves, or x equals negative 1 minus the square root of 5 halves. Yowza! I mean, listen, these numbers are not so nice, but hey, this is big boy and big girl math. You know, we got to be able to do it. So basically, if you have a coefficient on your x squared that's not 1, divide by it so that you do have an x squared coefficient of 1. And then you just go through the motions. You might have some fractions, but oh well, so be it. I'll do one more together, and then I'll have you try one on your own. One thing that's going to be different about this particular example is, holy cow, when we divide both sides of this equation by 2, we're going to end up with an x squared plus 7 halves x minus 2 equals 0. I mean, it's going to be all right, but kind of alarm bells are going off. We're going to have a lot of fraction stuff going on here. Just a heads up. All right, so let's go ahead and add 2 to both sides of this equation, yielding x squared plus 7 halves times x plus something, right, to complete that square, equals 2 plus, of course, that same something to keep the equation balanced. So what is that something? Well, half of 7 halves, 1 half times 7 halves, is 7 fourths. Okay, and that's the thing we're going to square. So we get 49 sixteenths. Oh my God, 49 sixteenths. Good God, that is tough. Woo! We're going to be all right. All right, the left-hand side, not so bad. We have a perfect square trinomial here. I hope you know that that is going to be x plus 7 fourths. Quantity squared, right? Just all we did was complete the square here. Here we're going to want to write this as one fraction. So I'm going to rewrite 2 as 32 sixteenths, right? Just because we want to have common denominators. 32 sixteenths plus 49 sixteenths, we end up with 81 sixteenths. Okay, so if you tell me that this number squared is equal to 81 over 16, well, I think that number has to be, well, what's the square root of 81 over 16? Oh, 81 is a perfect square. That's nice. Its square root is 9. Oh my God, and 16 is also a perfect square. That's nice. Its square root is 4. So just, 9 fourths. Holy cow. 9 fourths. Right, so x plus 7 fourths could be 9 fourths, or x plus 7 fourths could be negative 9 fourths. Holy cow. We're going to get some very nice answers here. We have no square roots anywhere. I mean, everything's groovy. If we subtract 7 fourths from both sides here, well, let's see, I think we're going to get, 9 fourths minus 7 fourths is 2 fourths, also known as a half. Oh, interesting. X equals 1 half. That's one of our solutions. Holy cow. Cool. And if we subtract 7 fourths here, negative 9 fourths minus 7 fourths is negative 16 fourths, also known as negative 4. Oh my God. X equals negative 4. Wow, we got some really, really nice solutions. That's pretty awesome. I mean, normally when we do this completed square, we get all sorts of like square roots and stuff, and it's kind of, not so groovy. Well, here's the thing. These two are rational numbers, 1 half and negative 4. You know what that means? It means that our original polynomial, 2x squared plus 7x minus 4, it could have factored. We could have factored this using the AC or splitting method, right? 2 times negative 4 is negative 8. Are there 2 Factors of negative 8 that add to 7? Yes, there are indeed. And you know how this one actually factors? It factors as 2x minus 1 times the quantity of x plus 4. Could have solved this guy by factoring. But that's okay. I still wanted to show you a kind of complicated example using completing the square. Okay, last example. Why don't you definitely pause the video, try this one on your own, and play the video, and we'll see how it went. All right, here we go. First things first, let's divide both sides of the equation by 2. We have x squared plus 3x minus 1/2 equals 0. We're going to add 1/2 to both sides of this equation. We end up with x squared plus 3x plus some unknown number when we complete the square equals 1/2 plus some unknown number. Half of 3 is 3/2. 3/2 quantity squared is 9/4. So we're going to be adding 9/4 to both sides. The left-hand side of this equation is x plus 3/2 quantity squared. The right-hand side of this equation, I'm going to write this as, let's see, instead of 1/2, I'm going to write it as 2/4. So this is going to be 11/4. All right. All right, so now we're going to kind of, you can say, take the square root of both sides of the equation. X plus 3/2 equals the square root of 11/4. Or x plus 3/2 equals the negative square root of 11/4. Subtracting 3/2 from both sides of the equation here yields us x equals negative 3/2 plus the square root of 11/4. Or subtracting 3/2 from both sides here, we have x equals negative 3/2 minus the square root of 11/4. I do want to make a note on some kind of notation things. The square root of 11/4, you can actually kind of divide and conquer here. Take the square root of the numerator, which is just the square root of 11, and take the square root of the denominator, which happens to just be 2. So we could easily have written this as x equals negative 3/2 plus the square root of 11 over 2. And even some people write this as negative 3 plus the square root of 11 all over 2. I mean, you know, this is just fraction skills here. So I wanted to make a note of that. Similarly, you could have rewritten this as, well, x equals negative 3/2 minus the square root of 11 over 2. Or x equals negative 3 minus the square root of 11 over 2. I hope you're kind of seeing that as well. And lastly, I just want to put this on your radar, a different notation. Some people will kind of combine these two and write it as x equals negative 3 plus or minus the square root of 11 all over 2. So I just wanted to at least put that on your radar as a notation that some people use so that if you see it, you know where it came from. And it also has a striking resemblance to the quadratic formula. So just wanted to put that on your radar. So, hey, that's solving equations by completing the square. Hope you found it helpful, and I hope you enjoyed.